Hello, and in today's tutorial, we'll be considering some essential functions for text output in R. So we'll look at the print function, the cut function, the message function, the paste function, the paste zero function, the toString function, and finally the sprintf function. Now to dive straight to the print function, it says the print function displays R objects and their structure. We know what objects are now in R, okay? So over here, I have created a this is a numerical vector stored in an object named numero1, okay? So if I want to check, let me just run this. So if I want to check what object numero1 is and its structure, I'll just bring the print function and I'll say numero1, and the moment I run, it will display what is inside or what is embedded in numero1. And as you can see, there is an index given to it. Take note, there is an index given to it. You could either go ahead to use the print function, or after creating the object, just like we've always been doing, you could just type the numero1 object and run. And the moment you run, you would see that you end up getting the same thing. Okay, the same thing you had for the print function is the same thing you're getting for just running the name. Okay, now this is a little icing on the cake. Okay, when I showed you the first instance and I came to the second instance, okay, you realize that I wrote it on a different line. Okay, I could have ignored it and written the second instance on the same line. Okay, it is possible. All you have to do is to bring a semicolon and then the next thing you wish to run. Okay, so once I run both of this, okay, you could see that the first one is for the print, and then the second one is for just the object name and then running it. Okay, same thing if I have a character object called say greeting, I'll say greetings, and then I assign hello world to it, and I run. I could come and use the print function and say print greetings, and the moment I run, okay, I have exactly what is embedded in the object called greetings, and also it has been indexed. Okay, good. Now let me ask, if we print greetings and or if we should print let's say object, if we should wrap object names in the print function and it gives us the output, how about if we want to print both greetings and numero1? We want to print both greetings and numero1. So to do that, we can't just go and type, let's say, greetings, comma, numero1. Okay, this won't work. This won't work. Why is it not working? Because over here, okay, it is only taking the first argument. Okay, it needs you to concatenate them. So the moment you concatenate this and that, it will work. But what is going to happen is that since you have a character and you merging it with the a numerical vector, okay, automatically they will both be merged or concatenated, or yeah, they will both be merged as strings. So if I should wrap this in the concatenate function, and now I say print this and that, okay, the moment I run, you see that it has printed both greetings. This time around, it didn't only print greetings alone, okay, but I had to concatenate them, okay. Since I'm looking at printing this and that, I had to concatenate them. And the moment I concatenated them, all the digits, okay, the numbers were transformed to characters. And you see that they all have quotes, okay, together with hello world. All right. Now let's move on to the cat um, function. Let's move on to the cat function. So what a cat function does is that it concatenates and prints text. So it is basically printing out text, and since it's printing out text, if we run some of the codes, okay, in the example I'm coming to give you, if you should run it, you realize that you won't have any index, okay, there won't be any index value there, okay. So let's say we want to print want to cut, okay, we want to say print this particular text. Let's say we want to print hello comma world, okay, hello comma world. You will notice that there are two strings I'm trying to merge in the cat function, and in doing that I didn't necessarily have to bring the concatenate function, okay, because the cat function in itself concatenates texts, okay. So when I run this, you can see here that it says hello world, okay, you can clearly see that here, hello world, okay, and there is no index. It has given the output as normal texts, okay. So what if I have, let's say, hello world, but then this time, okay, say hello world, I'll say hello, I have hello world, but what I want to achieve is that I want the hello to be on the first line, and let's say the world comes underneath the hello, okay. It's just like if you're working in Microsoft Word and you click you hit enter, okay, the text just jumps onto the next line. That is what we want to achieve here. To do that, okay, we need to bring a backslash, okay, a backslash and an n, okay, just a small n, okay, a backslash and a small n, and then we move on to the world, okay. So world, we have world this way, okay. The moment I run this, you can see here that hello is on the first line and world is on the second line, okay. What if you want the hello and world to be more spaced, okay? To do that, you add an additional backslash and an n, okay. So the moment you run, you will notice that there is this huge gap here separating hello from world. All right, let's continue to the message function. The message function. So what a message function does is that it just displays informational messages. So if you should build lines of codes and you use the message function to print out an information, it doesn't necessarily mean that it would interfere with the line of code that is going to be written, okay. It is basically going to just pass out information to the user, but then still proceed to carry out the code will still proceed to carry out whatever you have assigned it to do, okay. So for instance, let's say I want to message, let's say hello world. Sorry, hello world. Okay, I want to message hello world. Take note of how it appears in the console. When I run this, you'd see that the hello world is highlighted in blue, okay, or the text color is blue, not as black as the print and the cut. Okay, this is to just let you understand that, like I said initially, it is just displaying informations, okay, and it is not really going to interfere with your code. Okay, going forward, we'll come up with serious or in-depth codes, in-depth lines of codes that will be making use of these text output, and you would appreciate them better. But in this tutorial, I just want you to have a fair idea that these are certain functions you can use when it comes to displaying text outputs in R. Okay, good. Now we head to the paste function. All right. Sorry. We have I have spoken of that of the message function. Okay. We have another that is warning. Okay, a function that warns. Okay, and what that function also does is one and the same thing. It displays warnings. Okay, so if I have written a line of code and I want to warn the user on something, I could say warning, uh, let's say the the length of input is, let's say, greater than 500. Okay, it's just going to return the same thing. Okay, the warning message you are seeing. Okay, warning, the length of the input is greater than 500, just as it was for message. Okay, good. So let's head to paste. So what paste does is that it concatenates strings with a separator. It concatenates strings with a separator. So for instance, let's say I have my first string, this is my first string, let's say hello. Okay, and my second string is world, just as we have been discussing over and over. Okay, so this is my first string, this is my second string. Now I want to paste them together, I want to concatenate them together, I want to merge them together. Um, um, they are independent, okay, but now I want to knit them together so that it will be hello world on the same line. Okay, so I'll use the paste function. Okay, the paste function, and then state which objects I want to concatenate as strings. Okay, so I would say I want to paste first hello, and then next one is world. Okay, world. With the paste function, since it's already concatenating, we need not to bring the concatenate function. Okay, so we have this, and the moment I run, you see we have hello world. Now by default, the separation or the separator that has been allocated to separate hello and world by default is a space. Okay, so if you wish to define what exactly or what exact separator you would want to separate the first word from the second word, you will need to define it. So you define it by entering the sep argument, and then what do you want to separate it by? Maybe I want to separate it by a hyphen. Okay, so this, now observe the console. This is now going to become hello world, and you could see that the separator, which is a hyphen, has been indicated here. So depending on what you want to do, if it's the paste function you need to go with, you can go with it. Good. Now to the paste zero function. The paste zero function concatenates strings without a separator. So in the first one we had, for instance, the first string, which was hello, and the second string, which was world. Okay, if we are to use the paste zero function, the paste zero function merges both strings together, leaving no space. Okay, it just merges them together, and it has no separator. So let's say our first string is hello, and our next string is world. Okay, the moment I run this, you observe the console and you realize that hello and world has been knitted. Okay, they have been placed so close to each other. Okay, so the choice is yours depending on what you are carrying out. If you want to use paste zero, you can go ahead and use paste zero. If it is paste you want to use, you could go ahead to use paste. Don't worry, we would try as much as possible to make use of all these text functions. Okay, we'll try as much as possible to make use of all these text functions as we proceed with this tutorial. Okay, now the next function we'll be looking at is the toString function. So let's create a vector that has colors embedded in them. Okay, so let's say I'll call the object color box. Okay, and in the object name color box we want to store colors. So let's say orange. So orange, orange. The next thing we want to store is green, and the next is going to be red, and finally blue. Okay, now if I run this color box and I want to see what exactly is in color box, okay, I'll just say print what color box. Okay, or semicolon color box. Okay, and it's still going to return the same thing. Okay, so when I run, it says, okay, this is what you have in the object named color box. Okay, good. Now let's check the length of color box. We are still dealing with the toString function, but then I need to set the basis for you to understand better. Okay, so let's check the length of color box. So to check the length of color box, all we need to do is to call the length function. Okay, and then what length do we want to find? Color box. So when we run this, it says the length of color box is 4. Okay, another icing on the cake I would want to give to you, okay, is that either you go this way, length color box, or you can pipe, okay, you can pipe the object to the function, okay, that you want to make use of. Okay, so sometimes piping is done when, let's say, a particular object, okay, is going to be subjected to several functions, for instance. Okay, and wrapping it around several functions could be quite confusing, or it would make reading and understanding the line of code you wrote difficult. So you can pipe. Okay, so in piping, what you need to do is, or let me just break this thing down further. Okay, for piping, okay, the first um, objects, okay, the first objects results or output will now serve as the input for the next function. Okay, so let's say I have color box. So this is my object, color box, and I want to find the length of color box. Simply put, I want to pipe this, okay, into the length function without necessarily wrapping it in the length function. What I'll have to do is that I just call the vertical bar and then the greater than sign. Okay, so it's like taking this and you just passing it through to what? The length function. Now you leave the length function, um, you leave the argument in the length function blank, because whatever is here is what is going to be passed here. Okay, so now when I wrap this and I run, you see that it says the length of color box is still what? 4. So you could pipe. Okay, if you realize that maybe you are dealing with a lot of functions, maybe the object you are working with, okay, you are going to subject it to various functions at the same time, it is possible, or it is essential to pipe so that anyone that reads your line of code would understand. So I'll leave a comment here to let you get what was done here. So here we made use of function, we made use of the pipe operator. So this is the pipe operator. Okay, just like a water hose. Okay, a water hose serves as a means of transport where, okay, something moves from the source to the target. Okay, all right, good. Now take note, after creating the object, okay, color box, we checked and we said the length of color box was 4. Okay, now what the toString function does is that it converts objects to a single string. It means that it takes the number of elements in a particular object and just knits all of them as one string. Okay, now let me show you something. So let's use the toString function. The toString function, and then we have color box. We have color box. Okay, now take note of the console. Let me just run the initial thing we did so that you would appreciate it better. This was how it appeared. Individual elements bearing individual codes. Okay, but the toString function, see, the moment I run, you would see that all these have been wrapped around just a single quote. Okay, so now to see much of the difference that has taken place, okay, let us now find the length of color box, supposing we wrap it in the toString function. So we're going to pipe. Okay, we need to, you need to um, be used to piping. Okay, so we're going to pipe. So we take color box and we'll pipe color box to string. Okay, we'll pipe color box to string, and after that we're going to pipe it again. We're going to pipe it again to the length function. So we're taking an object color box into toString and then finding its length. Okay, it's the same as doing this. It's the same as doing this. It's the same as saying length, okay, to string, and then coming to write color box. Okay, this here is the same as that. This is the same as that. Okay, but if you observe this, you realize we have wrapped it so many times in a function, and you could easily miss the round brackets. Okay, and you later encounter an error. So if you realize that you're dealing with a lot of functions, and each function's input is going to be the output of a previous function, you can just pipe it. Okay, so if we pipe this and run, you will see that now the length of toString is 1, meaning that the toString function, like we said, would convert all the elements in an object into just a single string. It summarizes it into just a single string, and that is what you've seen here. Initially we had 4 elements, the length was 4, but now the length is what? 1. Okay, those that will want me to run this for them to see as well, you could see that here the length is now 1. All right, now we'll head to the final thing, that is the sprintf function. Now the sprintf function allows embedding variables into strings with specific formatting rules. Okay, for instance, we want to write a text like this, a string like this, let's say what, or we could say my name is, okay, dash, and I am dash years old. Okay, now what we want to do here in this string, okay, is that we want to source the name object, okay, and fit it here, the blank space you see here, and we also want to source the age object and fit it here. Okay, to do that, that is where the sprintf function comes in. Now the sprintf function has three, okay, three variables, okay, that could help you, okay, or that could take the place of the object that will be embedded into the string. Okay, so for characters, it is the percentage s. Okay, so percentage s, I like to call it percentage string. Okay, and for object numbers, okay, or numerics, we have the percentage d. I like to call it percentage digits. The last one we have is percentage f. Okay, which that is not the main focus for now, so I won't really dive into it. Okay, so like I said, we want to take the name, which is John, fit it here. We also want to take the age, which is 50, and fit it here. But this is where the sprintf function comes in. Okay, so we're going to use the sprintf function, and then we just take all of this into the sprintf function. But what we're going to do is that these spaces are going to be removed, and we're going to use the variables percentage s and percentage d. So my name is John. Okay, so since it's John and John is a string, we will bring percentage s. Okay, and I am, let's say, 50, or I am dash years old. The space here is supposed to take a numeric. Okay, so we'll say percentage d. Okay, now after doing this, the objects you have created that are storing the values or the element of your choice needs to be arranged in the same position as this percentage s and this percentage d. So going to do this, we'll say percentage s, percentage d. Percentage s tallies with name and percentage d tallies with age. Okay, now the moment I run this, you would see that automatically it has been given here. It says my name is John and I am 50 years old. Okay, so this is all I want you guys to know for now when it comes to functions that display text output in R. Okay,